Hello, how are you? We're back. Andrew Dunkley here, and good to be with you on the first 2023 edition of Space Nuts. And coming up on this edition, we will be talking asteroids, one in particular that came skimming past. I actually managed to put my arm up and touch it as it just went overhead. Asteroid 2023 BU. And we will be talking about some new space James Webb Space Telescope episodes. As you can see, I'm so rusty. Haven't spoken. My mouth hasn't opened for months. The James Webb Space Telescope's got some new discoveries. Surprise, surprise. And we're going to answer some audience questions about self-cleaning rovers, how spacecraft target small objects, and Earthrise. What is Earthrise and does it really exist? Well, we'll talk all about that coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me, as he always did last year and probably will this year, is Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. I hope I'll be on every episode this year. It was a pleasure to be on every episode for the last 7 years, so that's all right.
Yeah, it's great fun, and thanks to everybody for their patience. It's been a bit of a longer break than we'd normally have, but there were personal reasons for that. I won't show you the scars.
Oh, go on, Andrew, go on.
You really don't want me to. They're all down here. I've got 7 now. 7 scars. I've got 5.
That's pretty impressive.
Not 5, 6 new ones. So yeah. Anyway, it was necessary. It's done, and I'm at home recuperating. Haven't been back to work yet. This is the first thing I've done since getting out of hospital. But thanks to everybody who sent me their good wishes. I really appreciate that. That's lovely. And yes, all forward progress from here. As you can see, I'm feeling fit and healthy, and I've got a couple of things to do, Fred. I firstly want to say thanks to James in Cincinnati.
Excellent.
If you're on YouTube, you'll see this.
Yeah.
This is my Joe Burrow Cincinnati Bengals shirt, which I wore yesterday while they played. Very sadly, they got pipped at the post, but unfortunately they did not have the greatest game. So they won't be in the Super Bowl this year, but they had a fabulous season. And as I said to James, chin up, James, because they have the basis of a champion team. Their time will come. So thank you, James. I love the shirt. Oh, gosh, I so proudly wore it yesterday. I also want to send a shout out to Martin Berman Gorvine. Martin is the one that is trying to terraform our entire solar system.
Yes.
He sent me a couple of his books.
Oh, wow.
There they are. I finished reading this one. This is called The Double Life. I won't give too much away, but it's a great science fiction read. And it's one of those stories that keeps you hanging on because you're just busting to know what's going to happen. And that, to me, is a good story. So I won't tell you how it ended, obviously, but wasn't expecting the ending to be the way it was. Best way to describe the ending would be a soft landing rather than a punch in the mouth. But that I'm not saying that's a bad thing. I really enjoyed it, Martin. Great story. This is a short story. This is only, 25 pages. But that one is a good story in that it's kind of pitting science against religion. Really, really clever. Really clever. Love it. So thank you, Martin, for sending those through. The Long Morning of Heartwood and The Double Life by Martin Berman Gorvine. If you are a sci-fi lover, look them up and get them and have a read because they're excellent. And I think that gets me up to date. Anything you need to add, Fred? You've been, a man of leisure, or you've been busy, I suppose.
Yeah,
you never stop working.
It's been a busy period. There's been a little bit of leisure. I had a very lovely day. For 2 days, Friday and Saturday, cruising on a friend's boat in the Hawkesbury estuary, which was delightful.
Horrible place.
So that was my holiday. But very soon I'll be sitting in a meeting in Vienna of the United Nations Committee on the Peaceful Uses of Outer Space to talk about
Blimey.
what they're doing. So we'll keep you up to date on that.
Yeah, that'll be really interesting. Gosh, I would have thought that a subject like that could easily be solved in one paragraph.
Quite. It does have a number of paragraphs. You're quite right. You put your finger on the exact structure, but those paragraphs are onto great length, and there are many of them. And
I can imagine. Yeah, it's a dicey subject, and of course, it all goes down to the motivation of various bodies around the world, doesn't it?
Indeed, some of which are mentioned.
I'm sure they are.
Yes.
Okay. Now, let's get on to our first topic. And this was a recent near miss, as they like to call it in the popular press. I think I got sick of reading that this asteroid was the size of a minibus, but it was. Asteroid 2023 BU, it got pretty darn close.
Yeah, it did. 3,600 kilometres, or what's that, 2,200 miles or something like that. It's not the closest, actually. It is the fourth closest known asteroid encounter. That's ignoring those that actually hit the atmosphere.
I was about to say.
Yeah.
Not counting those that hit us.
Yeah, well, there were one or two, like the Chelyabinsk event back in 2013. That doesn't count because it didn't go past. But 2023 BU is pretty close to a record breaker. It's not really clear. Yeah, we heard a minibus sized, a delivery truck size. It is about that size, somewhere between 4 and 8 meters. 10 feet ish. That sort of 10 to 15 feet. The problem is you never see these objects as a resolved object, by which I mean you can just measure directly how big it is. All you see is a point of light because it's so far away. But yeah, it was discovered. This is the interesting bit. Basically 5 days before its closest approach, and guess who discovered it? I don't know whether you know this little factoid, Andrew.
I do not. I've been away, so I haven't really been keeping up to date.
Yeah, we would, given that the Earth is festooned now with asteroid detecting telescopes. Yeah, there's actually only half a dozen of them, and they do a fine job. But this one was discovered by an amateur astronomer whose name we've heard before. His name is Gennady Borisov. Who discovered Comet Borisov, the first known interstellar comet. So he's kind of royalty in the astronomical world these days. He lives and works in Crimea, which can't be the easiest place in the world to live and work, but that's where he works, and he's doing a fabulous job.
Yes, he is.
So it was discovered by Borisov, and of course there are mechanisms for how you alert the science world to discoveries like that, and that all happened. It worked well. It was immediately followed up by NASA Jet Propulsion Laboratory telescopes, and it was recognised that it would pass close to the Earth on the 28th, 27th, I can't remember. It was one day last week from our current vantage point. And there was no chance that it would actually impact the Earth. There are some interesting things, though, that have happened as a result of that close approach, because it passed so close to the Earth that its orbit around the Sun is dramatically changed. So it's before the close approach, it had a period of revolution around the Sun of, if I remember rightly, it was 351 days. I'm looking for the figure, but I can't lay my hands on it. It was about a year, but the gravitational pull of the Earth has accelerated it. And so it's boosted its period up to, I think it's 425 days. I see you looking it up, so you might be.
Yeah, I'm trying to. But
It's significantly changed its orbit. It pushes it It's at aphelion, the furthest point from the sun, much closer to the orbit of Mars than it was before. So that's nice to know that there's a gravitational interaction working well there. It's not going to collide with the Earth. That size of object would almost certainly burn up completely in the atmosphere, perhaps leaving a few bits of debris. It's smaller by probably a factor of 2 than the Chelyabinsk asteroid that exploded 30 kilometers above the city of Chelyabinsk in Russia. Some quite large fragments fell from that. I think the biggest was significant. I think it was a quarter of a ton or something like that. I need to look that up. But and it actually fell in a lake. It punctured a hole through the ice and fell in the lake. By the time it hit the ground, it was traveling, well, I won't say relatively slowly. It was still coming pretty fast, but it wasn't sort of this kind of speed that explodes on impact and makes a crater. It was by then most of its energy had been spent in the explosion above the town. But of course, as you and I have spoken about many times, that broke a lot of windows and injured a lot of people who'd rushed to those windows to see what the flash of light was in the sky.
Yes. Because the flash of light reaches them before the shockwave.
Yes, 90 seconds later, I think it was, that the shockwave arrived from 30 kilometers. So this is a smaller object than that, and it may well have exploded in the atmosphere, but it would have burnt up. But as it happened, it passed close to the southern tip of South America. That was where its closest approach to Earth was, and is now on its way out towards the orbit of Mars.
Yeah. So it'll go around again, I imagine?
Yes, it will. I saw some figures. I'm not even sure I could lay my hands on these quickly, but here we are. The orbit's changed. The calculations show that there is a 1 in 10,000 chance of an impact sometime between 2077 and 2123.
Ooh.
So that's late in this century and early next century. But that 1 in 10,000 chance is very low. And as time goes on, as the orbit of the object is refined, we'll learn much more about that. And it will probably end up, not being a collision risk. It's interesting that if a collision was predicted, whether you would need to bother doing anything about it, because it is likely to break up in the atmosphere. And especially as time went on, you'd be able to predict whereabouts the atmospheric entry would be. If it was over the middle of the Pacific Ocean, you'd probably just, wait for it to happen and look at the infrasound shock waves that it generated by seismometers and things on Earth. So not a threat. But once again, it alerts us to the difficulty of finding these smaller objects.
I was about to bring that up because we're very clever when it comes to discovering these things, but in recent years there have been a few instances where we've spotted them after they've passed us.
Yes, yeah.
And in this case, it was the 21st it was discovered, and it did the pass on the 27th.
Yeah, six days.
28th our time, 27th in South America.
That's right.
Yeah, so bit too late, really, to send a rocket up and divert it.
Well, that's right. Part of the good news of this story is that we know we can do that sort of thing after the DART experiment last year. But the other good news part of it is that the most dangerous asteroids are the biggest ones, or the bigger ones. They are the easiest ones to find. Yes, because they highly reflective. They reflect the sunlight, and our telescopes can detect them. So they're the mass extinction asteroids, 10 kilometers or so. There are 4 of them about that size known as near-Earth objects, and we know what they're doing, and there's no risk of a collision within the foreseeable future, which goes well over 100 years. But it's the sort of 100-meter ones that are really the challenge, because they are small enough to elude easy detection, but big enough to do serious damage if they do impact. And something like 39% of those, the statistical numbers are fairly clear. It's something like 39% of those are known. So there are a lot of those lurking out there, and that is definitely part of NASA's mandate to find them. Asteroids actually down to 140 meters. But what would really help would be a space mission, which is actually on NASA's horizon. It's being prepared. It's been pushed back a couple of times. This is called NEO Surveyor, and it's a spacecraft that would actually spend its time looking for these really difficult to find asteroids, ones in particular that orbit within the orbit of the Earth, or spend part of the orbit. I think the launch has been pushed back again to 2028, NEO Surveyor, but it's still on NASA's agenda. And I think it's been given a bit more impetus, actually, with the success of the DART mission. Now we know that there are things that we might be able to do if we had enough time to deflect the path of an asteroid.
I imagine, though, like you said, it's easier to find the big ones, but if they're the ones we have to move, they're harder to move.
They are, yes, much harder to move. But the big ones are more likely to give us more time to move them. If today we had an estimate that in 150 years' time there would be a likely impact between something, maybe a kilometre across, which actually is significant, then you've got plenty of time to try and move it. There might be different ways of doing that. You're really looking at a small acceleration. If you can do that earlier rather than later, then you've got a much better chance of changing the orbit so it misses the Earth altogether.
Yeah. Oh, dear. Yeah. I suppose it can be a bit scary because seeing things at the last second makes you go, gosh, what else is out there?
Well, that's right, yeah. But
that's what we're aiming to find with this new mission. But, every so often, it probably happens once or twice a year, I guess, Fred, does it?
Something like that. Actually, something this size probably does hit the atmosphere once a year. 4 meters or so, I think, is reckoned to be an annual event. One per year. 25 meters would be once every 100 years. So we've had that for this 100 years with the Chelyabinsk event. I guess the other good news part of this story, though, Andrew, is that 25 years ago, we wouldn't have known this thing made a close flyby. We just wouldn't have known that it was there. So it's because we know about these things now that it's scary, but it's also something that we can address. And I think the world of astronomy and space science is doing a good job at actually guarding us against these things, and will be doing an even better job when NEO Surveyor gets going.
If you want to follow up on that story, there's a great article in theconversation.com, and it also breaks down the hazards by numbers. So it'll tell you how big an asteroid has to be to do what sort of damage. And, you don't want to really look at anything above 100 metres. That's it's not good reading.
No.
Not at all. This is... Sorry.
I'm just going to say, written by Steve Tingay, who's at Curtin University, somebody we work with quite closely in our department.
Fantastic. This is Space Nuts with Andrew Dunkley and Professor Fred Watson. Let's take a break from the show to tell you about our sponsor, NordVPN. And as we're into a new year, Nord is kicking off 2023 with a brand new deal, 63% off NordVPN. And Judy and I have just come back from overseas, and we had a lot of situations where we were using public Wi-Fi over in New Zealand, which is everywhere. And once again, I felt fairly safe because I was using VPN to protect me from anybody who might try to get into my personal information, banking information, email systems, password systems, whatever it was. They couldn't get to it because I was using NordVPN. Now, the deal for the new year, exclusive to Space Nuts listeners, is fabulous. Now, what they are offering is different levels of plan over different terms. You can go month by month, although that costs you a bit more. You can have a 1-year plan or a 2-year plan. And there are 3 tiers within each of those plans. Now, the most popular is the basic service, which is giving you the high-speed VPN, malware protection, and tracker and ad blocker software. But if you go to Tier 2, it gives you just a little bit more, including the cross-platform password manager and a data breach scanner. But if you go with the top-tier plan, you get the whole bang lot, including 1 terabyte of encrypted cloud storage. And who doesn't need that these days? So there it is, and it is guaranteed. There's a 30-day money-back guarantee on NordVPN and all its services. So there is no risk in signing up for this service through our sponsor NordVPN. Now, the URL you need is fairly simple, nordvpn.com/spacenuts. That's nordvpn.com/spacenuts, and then just click Get the Deal and find the system that works best for you. That's nordvpn.com/spacenuts. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, to something we never talk about, the James Webb Space Telescope. And it's in the news all the time, but it's in the news again because of yet more discoveries. What's it uncovered this time?
This comes from a Webb science release, which is entitled Webb Unveils Dark Side of Pre-Stellar Ice Chemistry. And I guess that tells the story, really. That is to say that the Webb telescope has been looking deep into what's called a giant molecular cloud, a cold cloud in space, which is where we know stars will eventually form and planets will eventually form. So this is a nebula which is likely to give birth to stars. And they've kind of looked in the darkest, coldest regions of this cloud in order to analyze its contents. And what they've done is they've produced an inventory of elements and molecules which are basically the building blocks, not the building blocks of life so much as the building blocks of the building blocks of life, if I can put it that way. So all the things that we need for life, and the magic word is chons. I don't know whether you and I have ever spoken about chons before, Andrew, but chons is carbon, hydrogen, oxygen, nitrogen, and sulfur. And they are important ingredients well, first of all, in the atmospheres of planets, but also in some of the molecules that we consider to be the organic building blocks of life, like sugars, alcohols, amino acids, things of that sort. So that is why these things are of interest, because, you know, if you find them in a molecular cloud, what it means is that somewhere down the track, when a star forms with its planets, and we might be talking about 100 million years now, but those elements are there. And the fact that they're found in molecular clouds like this, which are very cold, cold means molecules. It means these chemicals can get together and actually form molecules, which include the ones that have been found, and they're actually ices, they're frozen, but they're things like carbonyl sulfide, ammonia, methane, methanol. These are, fairly complex organic molecules, and they are really, as I said, quite exciting to find inventoried in this survey. The leading leaders of this work are astronomers at Leiden Observatory in the Netherlands, and there's a really nice quote from Melissa McClure, I think she's the principal investigator of this work. She says, "Our results provide insights into the initial dark chemistry stage of the formation of ice on the interstellar dust grains that will grow into centimetre-sized pebbles from which planets form in disks. These observations open a new window on the formation pathways for the simple and complex molecules that are needed to make the building blocks of life. She says it a lot nicer than I did. And one of her colleagues, Will Roker, who's also at Leiden, says our identification of complex organic molecules like methanol and potentially ethanol also suggests that many star and planet systems developing in this particular cloud will inherit molecules in a fairly advanced chemical state. This could mean that the presence of prebiotic molecules in planetary systems is a common result of star formation rather than a unique feature of our own solar system, because we think that these molecules, many of them did actually make their way to Earth from the raw material of the clouds that the sun formed in the form of comets.
Mm. And you and I have spoken before about how Earth was potentially seeded and how it got its water. And the previous theory was that asteroids delivered the water. But what they've discovered here through the James Webb Space Telescope with the centimetre-sized pebbles from which planets form in disks, this is how they now think Earth got its water.
The water's already there, yeah.
The water's already in the dust, which turns into pebbles, which turns into disks, which turns into a planet.
That's right.
And then you get into the habitable zone, you got water.
So you're right, Andrew. And I think there's still that. So that is certainly one strong view of where the Earth's water came from. That it was embedded in the rocks from which the Earth was made. But I think it's fair to say that there's still. I think most people who study this sort of thing think that, yes, at least some of the water came from comets and asteroids as well. So I think it might turn out that it's a mixture. And it's one that's quite difficult to solve. You've got the thing about the isotope content, whether you've got heavy water or light water. We've discussed that in great detail in Space Nuts. So I think it's still an open question as to what the proportions were. How much was there in the rocks? How much was there brought in by comets
later on?
Yeah, great stuff.
So I suppose in announcing this discovery, they're saying that these planets could form. They could potentially be life-bearing planets in the future, but I suppose it depends on water content as to how significant that potential is.
Yep.
Would that be fair to say?
I think so. I think that's a fair comment.
I think last year will be hard to top in terms of astronomical achievements because we had so much going on, the DART mission, the James Webb Space Telescope, a couple other things that I can't think of off the top of my head because I've still got general anaesthetic foggy brain. But
doesn't show.
It was a standout year last year in astronomy. Yeah. Just remarkable.
And space science. There is... 2023 is going to have its highlights. We've got the launch of the JUICE mission to the Jupiter ice moons.
I thought you were going to say to the orange planet. Sorry,
one of them's orange. I guess Io is orange, but it's not an ice moon. It's a volcanic moon. That's, I think, scheduled for April. So no doubt you and I will be talking about that.
So the JUICE, where's that going again?
Jupiter's, it's going to check out Europa, basically.
That's a really good target.
I can't remember what JUICE is an acronym. Jupiter, Ice Moon, Surveyor, or something like that, probably. Yeah. I can't remember.
All right.
That's an S rather than a C, isn't it?
But that story about the discovery by James Webb Space Telescope is on the etherweb.org website if you want to check it out. This is Space Nuts. My name is Andrew Dunkley, and with me is Professor Fred Watson.
0G, and I feel fine.
Space Nuts.
Now, Fred, guess what we're doing?
It must be question time.
It is question time, and we've got some fresh questions. Now, I've been a bit rude, I'll admit to that, but I have wiped the slate clean. We are starting from scratch with questions. So if you've sent us questions, they're gone.
Well, no, that's not quite true, but If you sent questions last year,
that we haven't answered.
that we haven't.
If you sent questions last year, we're going to start from scratch. So get them into us through the website so that we can start collating them and answering them on Space Nuts for 2023. Now, our first question comes from Baltimore, home of the Ravens. And it comes... Sorry, Harold. It comes from Harold.
It's a whole new dimension on space.
Hello, Andrew and Fred. My name is Howard, and I am from Baltimore, Maryland, in the United States. And I have a quick question for you. I am so enthralled with our ability to send vehicles to Mars and have them, work almost autonomously, well, at least by remote control. And it's so thrilling to see what kind of data they're capturing and sending back. It's just amazing that we can even do that. But no matter how much we love those little vehicles and no matter how much they overperform our expectations, they all die. And it seems that every one of them dies because, a little storm kicks up some dust and covers their solar panels so they can't get solar energy. So my question is, with all that amazing technology and all those things the robotics can accomplish, why can't they just put a little feather duster on the end of a stick and let it, dust off the solar panel so the thing can continue to do science? It seems like the easiest, simplest, I don't know, no-brainer kind of solution. Do you have any explanation as to why they wouldn't consider that in the first place? Thanks so much. Bye-bye.
No worries. Thank you. Howard, I got his name wrong. I thought he said Harold. But, I already insulted him about his football team. I might as well keep it going. Thank you, Howard. The other problem with rovers is their wheels fall off. So
They do.
That generally brings them to a grinding halt. There have been a couple of cases of that. But look, it's a brilliant idea and so simple. Why? My thinking was maybe wiper blades just to scrape the solar panels clean. Why couldn't they build that into it?
A great question, and I won't insult you at all, Howard. Unlike my partner, who
it's my job.
It's a great suggestion. Let me just put it in context, though, because first of all, the big rovers that are currently exploring Mars. I'm talking now about NASA specifically. Perseverance and Curiosity. Both of those, neither of those have solar panels. They both have a radioisotope thermoelectric generator. The two previous ones, what were they? Gosh, Spirit and Opportunity.
Yes, that's right.
They did have solar panels, and on many occasions, those solar panels were cleaned by dust devils that passed over the spacecraft.
There was a really great case of that, I think. Was it Opportunity? It was like end of mission.
Yeah.
And then it woke up again.
It woke up, yeah.
Oh, okay.
Right. Okay. Yeah. But in the end, it was kind of, as Andrew's alluded to, it was mechanical failure. It was... Opportunity dragged one wheel for the best part of the second half of its career, and they just sort of wore out. The one spacecraft that has died because its solar panels got covered in dust is InSight, which kind of shut down towards the end of last year. That's really the only one that's carked it because of dust entirely. I think Spirit and Opportunity, that certainly dust was an issue, but there were I think one of them got bogged and was at a wrong angle for its solar panels to get light from the sun. I can't remember the details, but InSight definitely was end of life because of dust on the solar panels. And a nice addition might well have been a windscreen wiper or something to wipe the panels.
Because if you tried to use compressed air, I imagine on Mars, as soon as you sort of fired it would freeze, or the canister would freeze itself. I don't know.
Yeah,
I don't know if it'd be very workable. A wiper blade, though.
And
a squeegee.
These people at Jet Propulsion Laboratory who design these things, they're not without ingenious ideas, and so there must be
probably
a good
considered
reason
this.
why that has not happened. And I don't know what it is, but I'd quite like to find out. It may be that it's just too much
I
of an
think I
error.
know.
All right.
It's all to do with budget. Have you ever bought a spare part for a car?
It could be, there could be issues of lubrication for, the windscreen wiper. I don't know. I think it's an interesting suggestion, and let's make it our mission to find out why they don't fit windscreen wipers on solar panels.
I think it's a brilliant idea.
Yeah. Or
Who thought of that?
Some sort of mechanism. It was Howard.
No, he only asked the question. But no, it's a great question. I'd never would have considered it, but it does open up opportunity. Boom, boom. And maybe it's something he could write to NASA about and say, have you ever thought of? And
there'd be a really good reason why. It's not going to come back as, oh, what a great idea. We should have thought of that.
But you never know. I mean, we're talking about people who think in the highest levels of science and space science and astronomy. So they might not just go, oh, maybe we should put a windscreen wiper on that. I mean, it might not be front of mind.
I think that given that all these rovers have got, they've all exceeded their expected lifetimes by thousands and thousands of %. I think they've thought of most things, but there must be a pragmatic reason why it doesn't happen.
Yes, I'm sure it is.
And relying on dust devils is not necessarily the best way to do it.
No, but it works.
Yeah. I mean, maybe just one other comment on this is that Ingenuity, which does have a solar panel, that's the helicopter, has got its own way of cleaning things by simply flying through the air. Yeah. The solar panel actually sits above the rotors, but the downdraft from the rotors, even above them, probably is enough to blow stuff off. And certainly, as it flies through the air, that would
come off easily.
Yeah.
Yep. All right, Howard, thanks for your question. Lovely to have you first cab off the rank for 2023. Let's now move on to Sandy.
Hi, Fred and Andrew. It's Sandy here from Melbourne again. Hope you had a great Christmas and New Year's. My question today relates to orbits and space travel. In fact, I've got myself a little muddled up here. My loose understanding is the spacecraft essentially escape Earth's orbit and transition to an orbit around the intended target. Can you please explain how spacecraft travel to small objects like asteroids, such as in the case of the DART mission, where the gravity influence of that object may not be as big as our moon or a planet such as Mars? Is it as simple as pointing the spacecraft in the direction you want to go and light the engines? I assume not. Looking forward to your answer. Thank you so much.
Thank you, Sandy. The short answer is they fly, but they actually don't fly because there's no air, so they have no lift and therefore they cannot fly. But it's a good question, and I think there'll be a lot more mathematics to it than just point and shoot.
Although point and shoot is the basis of it, because what happens is when you launch a spacecraft like DART on its way to the asteroid pair Didymos and Dimorphos, you would start off by getting it up to a velocity that is greater than, 11.4, 11.2, I can't remember, kilometers per second. It's just over 11, to escape the Earth's gravity. And what that does is puts the thing into a sort of parabolic orbit, actually. It gets launched vertically, but then tips over on its side and heads off, kind of parallel to the Earth's surface. And what you have to do is to time your launch so that when it does do that trick of ending up parallel to the Earth's surface, it is also on an orbit around the sun that will take it past the asteroid. That's the critical thing. You basically take it off the Earth, you're lighting the engines up to give it the power to sit the thing in an orbit that is actually no longer around the Earth, it's around the sun. But it's such an orbit that will actually rendezvous or will interact, cross the orbit of your target object. Now, that's fine for something like DART, which was a one-way trip. It was designed just to slam into the asteroid. The aim was very precise. I think they were within a few kilometers of the target. A few meters of the target.
Yeah.
It was fantastic stuff. And so there would be corrections along the way, slight corrections, but the basis is just to point it in the right direction and light the engines. That's exactly as Sandy says. As long as you're doing that, you're going to wind up on the orbit that actually gets you to where you want to be at the time you want to be, when your target object is also there. So it is complex mathematics to do all that. Just to tie up the loose end, if you're going to an object where you want to put it in orbit, or you want to put your spacecraft in orbit around something, then you have to do all that we've said already. Put it in an orbit around the sun that carries you there, and then you have to basically brake your spacecraft using braking rockets to slow it down so that it's captured by the gravity of whatever it is you're in orbit around. And that might be something as small as a comet nucleus, because we talked long and hard about Rosetta years ago, a spacecraft which went into orbit around comet, what was it, 67P? Churyumov-Gerasimenko, if I remember rightly. That object's only 4 or 5 kilometers across. So once the Rosetta spacecraft had got to it, then it fired its braking rockets to slow it down enough that it would actually be captured by the weak gravity of the comet. And sure enough, it worked very well.
Indeed. Yeah, it's. I just think it's remarkable that we're able to build something, a machine, send it into space and fly it for months and months and months and sometimes longer, and insert it into the orbit of or land it on a tiny little object so far away. I just really admire that science.
Yes, it is.
It's fabulous.
Mind-blowing.
And that'll be happening a lot more often as time goes on. There's just so many more missions being touted, with so many more space agencies now operating, Fred. There's so many more opportunities to perform acts of science over long distances, and looking forward to Europa Clipper, is it?
Yep. That's the ESA version of JUICE, I think. I've got that the other way around.
Really
it might be the other.
to those.
Sorry, it's the other way around. JUICE is the ESA one. Europa Clipper's NASA. Yeah,
I'm looking forward to those missions, because there's so much promise in those ice moons, and can't wait to see what they see. Thank you, Sandy. We'll just do one more quick question before we wrap it up today, and this one comes from Silvio, who messaged us while we were on our break. Hi, thanks for an excellent podcast. You're listening to Space Nuts, Silvio, so I'm not sure. Anyway,
it's excellent. It's excellent.
If the moon is tidally locked with Earth, was calling the famous image Earthrise a little misleading? Yeah, that's a good question. Yeah. Now they're talking about one of the Apollo photos that were taken was taken from the lunar surface of the Earth appearing over the lunar horizon, and it was titled Earthrise. But the moon being tidally locked, so I suppose it does make you wonder why you'd call it Earthrise if it potentially wasn't the rise of the Earth. But I know what you're going to say, Fred, so go ahead.
Have you finished, Andrew? Have you finished?
I think so.
It was the Apollo 8 image of the Earth.
So they weren't on the surface; they were
in orbit.
There it is.
Right, and that's the trick. So it only rose because they were on an orbiting spacecraft, and the Earth, indeed, its appearance was that the Earth rose behind the lunar horizon, but that was only because the spacecraft was hurtling towards the lunar horizon at 1 or 2 kilometers per second. I think it's a bit more than that. So it did give the impression of the Earth rising. But Silvio's absolutely right. Seen from any point on the moon, the Earth doesn't rise and set. It always stays in the same point in the sky because of the fact that the moon is tidally locked to the Earth. So
if you were on the side of the moon where you couldn't see the Earth, you'd just have to go for a walk to watch
to see
the
it
Earth
rise. Yeah, quite a long walk maybe,
Probably.
with a few mountains in the way as well. So yes, Earthrise was a misnomer in that regard. It's not a misnomer if you think of your reference point as being sitting on the spacecraft, which is where the photograph was taken. So the Earth did appear to rise behind the limb of the moon from the spacecraft. But if
Now,
you were
would I
on the
be
moon,
right?
it wouldn't. Yeah,
Would I be right in saying that photo was taken on or about Christmas Day?
it was just before Christmas. It was. I think it might have been Christmas Eve. I do remember it. I can't remember the exact date, but yeah, it was very emotive stuff with a religious festival like that, very much forefront of everybody's mind, and here were humans in orbit around the moon. Quite extraordinary. Actually, they weren't in orbit. They just did a figure of 8 loop, I think.
It blew the budget too, because they had to get paid triple time for working a public holiday.
There you go. Yeah.
All right. Thanks, Silvio, or Silvano, I think it is. I'm going well with names today. Great to hear from you and get your question. Glad you're enjoying the podcast. And don't forget, if you've got questions for us, we need new questions because we're starting from scratch, as I mentioned earlier. So go to our website, spacenutspodcast.com or spacenuts.io. Oh, I even remember what they were. And you can click on the links there to send your questions. Now, that could be the link on the right that says send us your voice messages, or you can click the AMA tab. I'm doing this as I speak, and then you can record your audio question by pressing the start recording button. As long as you've got a device with a microphone, such as a smartphone or a tablet or even a computer. Most of them come with microphones built in these days, laptops, whatever. You can record a message and send it to us. Don't forget to tell us who you are and where you're from, and certainly don't forget to put your reviews down about Space Nuts through your podcast distributor. The more reviews we get, the more likely it is we're going to pick up more audience, and the bigger we get, the more we have to talk. No, I don't know. Something like that. But, yeah, we want to grow the family. And you can talk to each other too through the Space Nuts podcast group on Facebook, which is a really great group. Lots and lots of fun. Fred, we're done for another day. In fact, we're done for the first time in 2023. Thanks for coming back. I appreciate it.
Pleasure.
Doing this by myself would have been very difficult.
You'd have been fine, Andrew. You'd have been fine. You just get everybody's name wrong, that's all.
Yeah, well, I'm good at that.
No worries. No, always a pleasure, and I look forward to the next time.
Catch you soon. Fred Watson, astronomer at large, and from me, Andrew. Oh, and thanks to Hugh in the studio, who isn't around today because he's on holidays and didn't do anything. But thanks anyway, Hugh. Appreciate it. And from me, Andrew Dunkley, thanks for listening. Thanks for your support. Thanks for hanging around for a few weeks while we're away. We'll be back again next time with another edition of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.